Correct, yes. We're sitting on the unlocking savings, improving cleaning performance.
Okay.
Greg, you are back. You are still muted, but you're back. And it is 10 o'clock, so we can get this thing started. Welcome everyone. My name is Chris Crockett. I am maybe mute your phone. Um, we sorry. Um, we're happy to have you. I will be stepping out shortly, but my assistant Shannon is going to step in, and if anybody needs anything, I'm going to turn things over to Greg Lucabaugh so he can explain who's who.
All right. Well, welcome to the National School Plant Management Association's educational webinar. These webinars, they will be recorded and available on the NSPMA website. That's www.nspma.com. A little bit about NSPMA. We are a national organization and we touch people from across many states. And as I said, my name is Gregory Lucabaugh. I'm your host today. I'm chair of the educational committee for webinars for NSPMA. I'm also joined by Mr. Chris Crockett, our facility and ground supervisor at Turner USD-202. He's the past president of the Kansas Association of Directors of Plant Management and vice president of marketing and communication for NSPMA. Gloria Aguiar is our director of operations, and she's from Napa, California, and an NSPMA board member. So I'd like to thank Ed and the 3M team and their efforts. I'd like to introduce to you our presenter, Zach Dobler. Zach is an application engineer specialist for 3M, where he brings extensive experience in cleaning and disinfecting and chemical management systems. And we're with a dedication and experience in a comprehensive knowledge in all these things. Also, just a brief description about the accuracy of your chemical management systems. Many facilities unknowing suffer from inadequate chemical dilutions. And Zach's going to talk to us about some of those things. And some of the takeaways you'll get today is the impact of over and under dilution, of what that particularly means in your facilities, practical tips and best practices to ensure dilution accuracy in your operations, and chemical management innovation design to help you reduce labor dependency, maximize chemical performance, and help facilities plan chemical spending and usage. So with that, Zach, let's turn it over to you and let's get started.
Thank you, Greg. And thanks everyone for being here today. Again, my name is Zach Dobler, application engineer at 3M, and I'm really excited for this opportunity, this podium to talk to you. At Application Engineers at 3M, it's a fun way of saying tech service. We are the liaison between the sales force, the lab, and you as the customer. And so we're really dedicated to learning what works, what doesn't work, and helping educate and making processes overall better and more smoothly for your day-to-day operations. The topic that we're talking about today, unlocking savings and improving cleaning performance, is something that every facility, no matter the vertical, is looking to achieve. And post-COVID world here, we're spending a lot on cleaning, and we're seeing a lot in terms of surface residue. And I think the biggest thing that we want our customers to think about is how are you getting that cleaning chemical that you're using? And most often, when we're talking about cleaning chemicals, we're using a chemical management system. So the accuracy of that chemical management system is really paramount to your overall success. So I'm Zach. I just wanted to make sure that you guys saw my face here. So here we go. Moving on. So why do I have a picture of vehicles here? Or why is there traffic and why is there a clean road? I think if I asked every single one of you, which road would you rather be on? And where would your blood pressure be the safest? I think we'd all say a clean, empty highway. We'd rather drive down in maybe middle of Wyoming versus downtown LA or in rush hour traffic. outside of the nerves, outside of the frustration that traffic drives, if we strictly think about our vehicle and our gas mileage, when we're in traffic, when we're stop and go, when we're transitioning and moving via and changing inertia, essentially, we're spending a lot of energy. And with that, you can't plan on when you're going to get somewhere. You probably can't plan on your gas mileage. And I bet you everybody here would say, probably, I'm going to be spending more money going in a traffic situation versus an open highway because I can't plan. And you're moving very inefficiently through that. So that takeaway there is that traffic has a lot of synergy to chemical management. I've had the opportunity to travel the country in over the last month and a half in many different parts of the country, and traffic specifically is something that resonated with me and this topic of chemical management. Now, this picture's fun, more just to get a chuckle out of the audience here. But the trend is still simple and still true here. When we're changing the water pressure or influencing your water pressure on a hose, this dog, for instance, he's probably doing this for kicks and giggles and more entertainment. But do you think this is a really efficient way for him to drink this water or her? Absolutely not. If I took my thumb and put out the end of a hose and could change the water pressure or the speed or water flow that's coming out of the hose, it's harder to catch that water. It's harder to drink out of that specific reservoir, and it's harder to fill a bucket in that situation. When we impact water pressure, things happen. Performance changes. So ultimately, I have this noodling in the back of our mind. Consistency is key to unlocking optimal performance. No matter the solution that you have, no matter the operation that you're experiencing, consistency is key. And so when we're talking about chemical management, we're talking about cleaning. We're talking about cleaning chemicals and disinfectants, another big hot topic. From our perspective, the manufacturer's perspective and 3M, and from an application engineering perspective of going to talk with your customers and learn what's working with them, we're constantly hearing that they're getting inundated. Customers are getting inundated with, here's the new disinfectant. Here's my more effective cleaning product. Here's my more sustainable solution. Oh, this product's going to be improving your handling or your experience. We're also hearing there's a lot of labor challenges. Now, these are all great and dandy, and by human nature, new is something that we're always going to gravitate towards. Improved, those are just kind of trigger words in that instance. And in some instances, we do need new and we need improved solutions. But I would like us to all consider when it comes to cleaning, it comes to chemical management, why are our current solutions not meeting our needs? Now, when we think about that and we think about the current solutions we're using, why are we using them? The soils that are used today, I guarantee, are the same as they were a decade ago. The dirt is probably similar. The soap scum in your bathroom, probably similar. The mineral scale is probably similar. The cell structure of the microbes that we're experiencing on this earth, they're most likely going to be very similar. So why are our current solutions not meeting the needs? Why is my floor cleaner not cleaning as effectively as when I was sold it on or when it was showcased to be working? Now, another instance when we're talking about chemical management, I guarantee a lot of us have seen this in your facility. One day it's a darker shade in color, and one day it's a lighter shade in color, especially when you're using chemical management. If I ask that to this audience here, I guarantee a lot of us would raise our hand to say that this is a real thing. We see this often. Which one is accurate? That's always the question that we have. Qualitatively, by the naked eye, we know something's not right. We know something's not being influenced correctly. And most likely that's related to the accuracy of your chemical management system. It's not working the same as it did the day one, as it is day two, as it is day three, as it is down the road or a year later. And why is that the case? We need to understand, and it's something that we really like to advocate for our customers, is that the accuracy of your diluted solution is your key to success. If you can control and have an accurate dilution, you can plan on the spending, the procurement, the yield of the chemistries you can have. Your compliance is most likely, you're going to have that more equal set of mind that you're going to be meeting those EPA specifications to kill the germs that are needed. Your efficiency is going to be planned. It's going to be improved based on you can plan on that product working as when it was sold to you. And from a sustainability perspective, you're not wasting chemical. You're not having to use too much. You're not having to use too much water. Maybe you're not going through as much product as you need to, so you're reducing the amount of carbon footprint of shipping product into your facility or bottles in the environment. Accuracy is so important when it comes to chemical management. Your chemical management dispenser, if we had to compare it to an employee, it's an employee that you want to show up. It's an employee you want to do its job. You want it to work appropriately. If that employee didn't show up and did a job that was half of what it was supposed to do, you'd have problems. You consider why am I having this person in my facility? If we think about that methodology with your chemical management system, the same spirit is true. At 3M, we're really of the mindset that if your solution's not diluted appropriately, what's the point? You could pay the surgeon the most money in the world if you're a healthcare institution, and they could be doing the best job they can. But if they're not cleaning appropriately, again, what is the point? And a lot of that comes back to your diluted solutions need to be at that proper prescribed dilution or concentration in order to clean that facility for you. Now, there's things working against your chemical management system. There's things working against us, and when it comes to cleaning, the spirit of chemical management. One, avoid direct concentrate exposure, and two, control the dilution so we don't have that junior chemist mentality happening within a facility. We want this dispenser to deliver a diluted solution so you can worry about cleaning your day to day and not what or how much do I need to put in here. Now, I mentioned there's factors that are going against us here, and the biggest one is water pressure or water flow. So the building design, the location of the dispenser in that building, your water source, the age of your plumbing, distance to the water supply, the capacity of your building, how many toilets are being flushed at one time, or how many sinks are being turned on. All of these things can impact your water flow. Now, if you've been in a hotel recently, you're definitely going to know this, but even at home, when you're in the shower and you notice that water flow or water pressure change, it's pretty frequent. And sometimes it can relate to temperature change. It can relate to a difference in opinion or a difference in experience. But this is real. And this water, the one big thing to take away is that water pressure is something that we really can't control, and by minute, by day, by time of the day, and depending on the factors that are influencing your water pressure, it can overall influence your chemical management system. So these are things that we can't change. We need to accommodate for them. Depending on how that flow is changing, you get two different phenomenon. One is over dilution, so too much water, or under dilution, too much chemical. So if you're experiencing a situation where you have over dilution, most likely there's going to be a potential for a decrease in efficacy of your cleaning solutions, whether that is in performance or if it's a disinfectant or sanitizer, not quite meeting that EPA level or specification to kill germs. That is the really big scary piece to that. You could also be influencing a situation where you have ineffective cleaning ability. So you have too much water in your solution. So you're going to have that come to that moment of, oh, maybe I need to clean this surface again. Why am I purchasing these expensive cleaning products when it's mainly water? So these types of situations do arise. Under dilution, so the other side of the coin, is too much chemistry. So increased residue is a big one. Surface damage, safety. The concentrate is more so what you're closer to now than the diluted solution when you look at that SDS. And then ultimately that increased cost. You can't plan on how much chemical you're going to use. You're going through it at a much quicker rate. Thus, you're going to be spending a lot more money in your facilities day to day to accomplish a task. This is huge, and it doesn't matter the vertical, whether it's education, healthcare, or hospitality. So I was mentioning this, the results of over dilution here, so that too much water, not meeting that EPA specification, the amount of re-cleaning that you're going to have to do, and then ultimately the cost, the labor that you're going to have to re-clean or do things more often than you expected. Under dilution, these are real life examples. of looking out in the real world of chemical incompatibility. So something could be going on here of using the wrong product in the wrong spot, or it could be that you're using a product that was inaccurately diluted. It's too concentrated, thus giving you these results and making irreversible damage to your surfaces. But beyond that, it's that increase in spend, whether it's replacing that surface, having your employees clean more often because they have to remove that residue. So cleaning things 2 times versus once, or ultimately using too much chemical, having to replace it in your facility. So this over and under dilution factor is a really big deal. When we're talking about the under dilution factor of that being too much chemical in your diluted solution, you're moving closer to that concentrate. Now, I love analogies. I love pictures. It helps me learn. It also makes it just more real to situations. And you might be thinking, okay, Zach, I get it. Under and over dilution are issues. But why are you showing me peppers? What is the focus point on that? Now, if you were an alien coming to this planet and you had no idea what these vegetables were, and you just knew that a pepper in this instance was a red vegetable, if you bit into a habanero versus biting into a bell pepper, I guarantee it'll be a much different response. Now, the pH profile of the bell pepper is around 6.2, so we're going to round that to 6. Habanero pepper, 4.9-ish, so we'll round that up to 5. Now, when you're thinking about the pH scale, I'm pivoting to the pH scale because it's so important. When you're looking at a new chemistry to bring into your facilities, I encourage you to look at the pH. The pH is a very simple way to understand, from a compatibility standpoint, what we're dealing with. It's one of the first steps to evaluating a new chemistry in your portfolio, and it's something that us as application engineers, it's where we look to first as well. But understanding that pH scale and how close you are to different levels can help you understand the corrosivity or caustic nature of those solutions. So back to the peppers. Now, if I were to tell you that one pepper was a 6 pH and one was a 5, only one step away, we may think, oh, well, it's really not that drastic, or it's not that change of an improvement. But as you see with these peppers, it's a drastically different immune response when you bite into one versus the other. So it's important to understand that corrosivity in every step on the pH scale away from 7 is 10 times more caustic, 10 times more corrosive. So when we're dealing with cleaning chemicals and say that it has a pH of 6 or it has a pH of 7, and maybe it's a floor cleaner, that could be the difference between a heavy duty floor cleaner and one that's more mild. Another big important piece here is our regulatory entities. So the DOT and OSHA, most of us are familiar with those two entities. DOT looks at the roadway, accidental release of chemistries on the roadway or potential solutions on the roadway. And their level of corrosivity, or what they determine to be a corrosive substance, is under 4 or greater than 9. Now, OSHA, workplace safety, SDSs are their name of the game. They look at anything under 2 or greater than 11.5 to give you that corrosive pictogram. Now, me, when I initially read this, I'm like, dang. So we are okay to be more so exposed to corrosive substances at lower or higher pHs with our natural skin, versus DOT is seeing things to be more conservative in that nature. Why is that the case? It's all about surfaces. It's all about accidental release. So DOT realizes that even at more mild pHs in comparison to OSHA, we can still see surface damage. And so with that in mind, when we're thinking about facilities, we're talking about chemical management today. Your concentrate, and the reason you chose chemical management in the first place was to get away from handling the concentrate. Concentrates are concentrated so that you can have a higher yield. You can have a solution that goes further once you dilute it in that fashion. If you are diluting inappropriately and you're under diluting, so it's way more concentrated than needs to be, you're closer to that concentrate pH. Thus, your surfaces are going to be more exposed to a solution that's unintended and thus could cause you that surface damage. And even if it's 1 pH, now rounding these peppers example, you could have a different results. At 3M specifically, when we're talking about our floor cleaners, our number 3 is our neutral floor cleaner here, as you see on the left. The pH for that is at 7. Now, if our customers were complaining or needing something related to a more heavy duty solution for cleaning their floors, and maybe it's winter time and up in here in Minnesota, we get a lot of salt residue. We need something just going to be a little bit stronger than the 7 neutral pH. We offer our customers our number 24, which is our heavy duty floor cleaner. Now, if we are just looking at these by title of a green seal floor cleaner, another green seal floor cleaner, we could get in some really big trouble really quickly in terms of we're not looking at the full picture. We need to look at the pH. And when it comes to chemical management, we want things to be diluted accurately so we get that intended pH of the solution. So another big factor in chemical management is how do I validate my diluted solutions? How do I know if something is diluted appropriately? So the first thing that we naturally do is by visual. So a qualitative viewpoint. So when we look at diluted solutions, we think about color. We think about volume. We think about suds. And that's kind of the way that we can qualitative reason with our diluted solutions. Okay, today it looks about the same color as it did yesterday. Or maybe today it doesn't look like the same color. Or maybe I'm filling up this bucket faster. In the lab here at 3M, we have that ability with a device to change the water pressure that dispensers are experiencing. And with that, we can ultimately see how accurately these dispensers are diluting. Now, when you look at these images on this slide here, you can see that we adjusted the water pressures from 30 up to 80 psi. And on the left here, you can see there's a consistent color, a consistent volume. Naturally, that makes sense. We would come to the impression that this is at least accurate. It's giving me what I intended it to do. On the right here, you can notice the volumes are drastically different from 80 versus 30. The colors or the hue of the solutions are different. The suds in the solution are different. Qualitatively, we know something's not quite right. We call this the beer test. Over on the right-hand picture, you got your IPA on the left and you got your light beer on the far right. We know something's not quite right. We know if we drank those two solutions, beer that is, you'd have a completely different immune response to which one it is or flavor profile. You're going to have that same type of situation go down with your cleaning chemical. You're going to have a much different cleaning performance, much different experience when utilizing it if they're not diluted appropriately. We get this question in the lab. Okay, Zach, this is cool. I get it. The right something's not quite right. The left looks right. But what is right? And that's a question that we might not be able to answer without doing some analysis or calculations to figure out how close we are to mixing to the yield of the product. Another scary feature to chemical management that honestly deserves a lot more attention is who is regulating that space. Now, we know the EPA, when they look at germs and efficacy of biocides and pesticides and our disinfectants specifically, we know the FDA and how they are regulating different areas of our world. But who's regulating chemical management? If you think about it, there's so much power, there's so much faith in our chemical management systems to deliver you a solution that's intended, to deliver you a solution that's going to clean your facilities or deliver a solution that's going to kill those germs that we so need to do. And I'm here to tell you there's nobody. It's the Wild West when it comes to chemical management. There's no specification that a dispenser needs to be operating or accommodate for those ever-changing water pressures that we communicated earlier. It's all up to that manufacturer. It's all up to that dispenser in itself to accommodate for those water pressures that we hope that it's doing, which makes it quite scary. There is a part to chemical management systems that is regulated, and that's backflow prevention, so preventing chemical from going back into the water supply. But for your dispenser to be working appropriately, delivering that solution that you need for your facilities day to day, it's quite frankly, it's an open book. And so that's why we encourage our customers, we want to empower our customers that when they're going into a discussion related to chemical management and picking those chemistries to utilize within your facility, make it a priority to evaluate the dispenser because that dispenser is equal to or more important than your chemistry that you're bringing into your facility. Because if it's not working, your diluted solutions aren't working. So historically, when we're talking about disinfectants, specifically, those are the ones that are closer to our heart, killing those germs, keeping us clean in our facilities. Microbial control is definitely the area of higher scrutiny, especially in education and in healthcare. And there's been two methods on the marketplace in our industry for testing those solutions and whether they're working appropriately. So one of those is test strips. And so QAC test strips are a very common one. You have a strip that changes color once you dip it in the diluted solution, and you compare that strip to a scale or a key on the side of the bottle of these test strips. The issue with these, I'll start with the positives. The positives, it's quick. You'll almost instantly know based on that color change what you're going to be comparing to, and you can have a result that you can put in your folder as your audit is being conducted. But the negatives to that are it's very subjective. Then they're also not super accurate based on the scale. I know one of my colleagues on here is Ed, and so if Ed was looking at this test strip and it was supposed to be brown, maybe he sees one color shade of brown versus the difference that I see. So it's all dependent on how well you see color and how well you compare to the key that your device is or your test strip is. So there's definitely some nuance to that, and there's a level of subjectivity that you need to make on your as a facility. The next method that can be utilized is a titration. And so it's kind of that junior chemist technology, drop, drop, drip, drip, and a color change to understand how accurate diluted solutions are. Definitely more complicated, definitely more sensitive, but can be more accurate than a test strip dilution. You can get down to that nearest 10 parts per million active of your disinfectant versus being in a range of 100 or more. So there's those two methods that are utilized in industry, but there's also definitely methods for auditing the dispenser, so more mechanical validation methods. And we like to refer to those mainly as your dilution tips. So if we're familiar with dilution tips, some dispensers on the marketplace require manual change or implementation of these tips. One, to have a different dilution, and two, to maintain how your dispenser is operating. Now, most four quad cabinets, I'm going to call it, or four quadrant dispensers, where you just turn a knob or click a button for it to dispense for you, operate on Venturi technology. So utilizing that siphoning effect to extract water or extract chemical from a bottle of meat in the water supply to provide that accurate dilution. These dispensers require a dilution tip. And so these dilution tips are different orifices or different sizes depending on the dilution that you need to be. Now, for dispensers to work appropriately with these dilution tips, they need to be changed because when this dispenser is not in operation or using a very, I'll say, sticky or gummy disinfectant or chemistry, it has the potential to clog these tips. And if these tips do clog, you may be just dispensing water. So you run the risk of inaccuracy with your dispenser. So this is a manual calibration or method that you can utilize to make sure your dispenser is operating outside of water pressure. So cool. These are really good industry standards. These are industry practices. This is kind of what's going on when it's related to chemical management. What is 3M doing in this space, or why are we spending so much time talking about it? We have a method at 3M where we can test diluted solutions because we understand those validation techniques are not at the level that we need them to be. And frankly, they're too subjective. And so our method is weighing a chemical bottle before and after a predetermined volume of dispensed liquid. So what do all those words mean to me, Zach? When you're looking at a bottle, and I'll use a disinfectant as an example, they're going to have a dilution ratio. Inherently, you look at the bottle, it has a volume or how much chemistry is in it, and then it'll also have a yield. So how many gallons or how far that bottle can go. So inherently, based on having that yield, a specific amount of chemistry is required for every gallon of diluted product. And so we're holding these bottles to that test by weighing them before and after a predetermined volume of dispensed liquid. And by doing this math calculation, which we've worked into a spreadsheet that our sales reps are equipped to discuss, we can help the customer realize how accurate their dispenser is and how close it is to the yield that that bottle says it's going to be. So we're taking out that subjectivity and moving to a more mathematical scale of understanding dilution accuracy. This methodology can highlight the real reason of why 3M's in the chemical business and what our merit is to our chemical portfolio. So our dispenser is called the 3M Flow Control. And the reason why it's called flow control, we're not super creative with our names, is we're controlling the flow of water to each of those chemicals, each of those quadrants in the cabinet. By maintaining a consistent flow of water, we can ultimately control your dilution and give you a more accurate dispense solution. And by utilizing flow control technology, we are 55% more accurate than the next competitive system on the market. So now hopefully it's now kind of coming together, coming full circle. So why did Zach talk about vehicles? Why did he talk about gas mileage? And why did he talk about the dog trying to drink out of a hose? Now, stop and go traffic. Gasoline engines operate via Venturi technology as well. By not consistently allowing that gas into that engine or thinking about that dog in the hose, by changing or having extreme water pressure, he or she can't accommodate for that water flow. Thus, you're going to have an accurate level of gas mileage. You're going to have an inaccurate level of understanding of when I'm going to need to pull over and get gas, or the animal, the dog, an accurate level of how much can that dog absorb? How much can he drink or he or she drink out of that specific situation? Now, relating back to chemical management, if we had water pressure changing all the time, which it does, how are we going to have an accurate dilution? And how does that siphoning effect operate and how it's going to be influenced? So we need flow control technology within our dispensers. And if not flow control, we need some sort of flow regulation technology in competitive systems in order to accommodate for that water pressure change that is inevitable and it's going to be changing. We understand that this claim of 55% more accurate is large. And it is a little bit of a concern to our competitors too. It's like, how can you make that claim? Well, we've tested against all the leading competitive systems on the marketplace, and what we've come to a realization is even within the pressure ranges that they advertise that their dispensers are working appropriately, there's inaccuracies. And it all relates to the changing in water pressure. We're not accommodating for the change in water pressure like we should. Thus, we're getting inaccurate dilutions at the end of the day. So 3M, we have these claims. We're saying this. Okay, sweet, Zach, I believe you. There's a lot of studies that are coming out there as well. And then this one specifically came out in October last year. The Cleveland VA Medical Center did a study of automated dispensers. And what they divulged or learned is out of the 10 hospitals that they're looking at, 9 out of the 10 of them weren't working. They're observing inaccurate diluted solutions, disinfectants not at the level that they need to be, disinfectants with no disinfectant in the diluted solution. And this is healthcare, quite scary. There is a need for regulation around chemical management, and there's a need for facilities, whether you're education, you're healthcare, you're a theme park, it doesn't matter, to understand that your dispenser is the most accurate piece to your chemical management portfolio. Because if it's not working appropriately, what is the point of your diluted solution? Now, fun fact in this study itself, and it speaks to the flow control technology in action, is the one healthcare facility, Hospital 5 in this study, that was utilizing flow control was only one with expected concentration of disinfectant. So disinfectants at the level needed to kill germs per the EPA label. It's alarming thing, and it's the reason why there needs to be technology in your dispenser to accommodate for the ever-changing water pressures. Now, this specific study has led to the adoption of a mandate across VA medical centers countrywide. All of them have to now audit their automated dispensers to make sure they're working appropriately, and if not, they have to have an action plan in place. So if I had to look at my little crystal ball, this is a trend. It's a start. It's a reason, and it's a very valid reason for dispensers and automated dispensers to be audited and to make sure that they're working appropriately and accommodating for the water pressure that we can't control. On top of performance, human health and safety, as well as efficacy of cleaning solutions, sustainability is massive. and we all want to make the world a greener and healthier place. And when it comes to cleaning and comes to chemical management, we want to reduce our carbon footprint. We want to reduce the waste that we're using and prevent surface damage. And so you can definitely harness a lot of this with chemical management. When your chemical management system is working appropriately, reducing amount of water and chemical waste, preventing surface damage and equipment replacement, reducing packaging or how many cases or bottles of products I need in my facility, and lowering that carbon footprint of transportation into facilities. You can do that. You can harness that. You can have a sustainability message and footprint with the accommodation of a chemical management system that is working for you and accurately. So chemical management, as I bring this to a close, is super important. And the results of an accurate dilution can yield great benefits for a facility. And it's honestly the first place that we should have facilities look when they have that question. I need to reduce spend, or I'm having a hard time with my labor. I need some innovation to reduce my labor dependency, or I'm seeing my surfaces result with more residue or look dirtier over time. The quick and easy way, or the first step, should be looking at your dispenser. How is it working for you? Because that's what's delivering those cleaning solutions, whether it's disinfection, floor cleaning, degreasing, bathroom cleaning, glass cleaning. That's what's delivering those solutions for you in your facility. And if those aren't diluted appropriately, you're either moving closer to your concentrate STS, so really caustic, or more so concentrated, or you're moving to the other end of the spectrum of closer to water where you're going to have to re-clean. So the big goal behind this presentation today was to understand that chemical management is so important, and we need to spend more time evaluating it. And I hope that this presentation was fruitful for this team. And if there's any and all questions, I think this is the perfect time to answer those. And if not, feel free to connect with your local 3M representative or application engineer like myself, and we'd be happy to talk. So thank you for your time.
Zach, thank you so much for an excellent presentation. And I do have a couple questions I think that maybe you could hit back on. Water pressure and performance. Could you speak just a little bit more to water pressure and performance?
Absolutely. So water pressure is something that we can't always accommodate for. It's always going to be changing. And when you're not accommodating for that water pressure change, it has the potential to affect your chemical management system. So when you're talking about performance specifically, over dilution, so too much water in your diluted solution. So depending on how that dispenser operates, and maybe your water pressure is really extreme, so there's more water in that diluted solution than chemical, you're most likely going to have to re-clean that surface because you're mainly just using water. You're not using what you purchased that cleaning chemical to help you with the chemistry that's in it. So ultimately, if you're not harnessing the right dilution, you're overall going to get a change in performance, whether that's too much chemical, so you're exposing too much chemical to your surface, increase in residue, surface damage, or the other end of the spectrum, you're using mainly water, so you might have to re-clean the surface and you're not getting the benefits of that overall chemistry.
Excellent. And Gloria, did you have a question or two? I think she's trying to get back with it. Just one more, and then I think we'll bring this to a close. What changes the color of chemicals? For instance, you were very specific about, I see the same chemical on three different carts, and they're all different colors.
Yeah, really good question. Most common question we get is related to color change. So that speaks to qualitative, just by visual sight, that something is not quite right. And so when we do see the color change, most likely it's an influence to your first question of how does water pressure impact performance? And so that water pressure is changing. So it's probably equating to the factor of it's due to that Venturi technology. So most of these dispensers operate in that fashion. That siphoning effect, either not allowing enough chemistry in that diluted solution, or the other way around, offering too much chemistry in that diluted solution, thus more chemical in the water, it's going to give you a darker hue versus lighter, it's going to be closer to that water color.
Thank you. Ed, in closing, anything you'd like to add, sir? And first of all, thank you for all the work you've helped put into this.
Absolutely. No, thanks for coordinating this and getting this out to your members. Excited about participating in the first webinar that you guys did to your members. Looking forward maybe to doing one in the future, and appreciate all the help in getting this going.
All right. Well, first, I'd like to thank all of you that attended. We will be posting this on the NSPMA website under the educational section for those of you who need to go back to it and review. I'd like to thank Gloria and Chris for their work as NSPMA board members putting this together. And I want to remind you, be on the lookout for new, innovative NSPMA webinars that will be coming. And Zach and Ed, thank you. Thank 3M for all you do to help make safer and cleaner environments for those who spend most of their day inside and do these things. So without that anymore, thank you guys very much. We'll talk offline, and have a great day, everyone. Thank you.
You.